Hi, my name's Stuart Lynch, and this is the second video in a two-part series where I explore new features introduced for SwiftData in iOS 18. In the first video of this series, we created a new preview modifier that allows us to import data from a JSON file to populate an in-memory container that we can use in all of our previews. In this video, we'll build dynamic sorting and search capabilities of the app, and I'll introduce you to a new expression macro that we can use to create complex and compound predicates for our SwiftData models. I love getting your feedback, so if you enjoyed this video, please give it a thumbs up and leave me a comment below. Make sure you ring the bell to enable notifications and get notified whenever a new video is released. And if you want to support my work, you can buy me a coffee. A link is in the description. There is a starter project for this video, and you can download it from the link in the description. If you completed the code for the first video in this series, you can continue on from there. Otherwise, download the completed project for part 1 and carry on from there. There are 3 branches, so make sure that you do download the part 1 completed branch, as it has the starter resources and the completed code for the part 1. The part 2 completed branch contains the completed source code for this video and the completed project. You can just download and expand the zipped archive. The project does require Xcode 16. If you haven't watched the previous video in this 2-part series, I suggest that you do, because in that video we created an import model and generated some JSON so that we could preview the data in all of our views. And we do this by using a preview modifier called mockData that creates an in-memory based SwiftData container. Well, what we want to do is make sorting and filtering dynamic by way of creating a picker for sorting, and then another one that will allow us to choose any one of the fields for our books array and filter based on criteria entered into a text field. If you want my full series on this topic, you will have learned what we must initialize and update a query based on those selected picker values, so we'll need to move our book list into a separate view so that we can perform the query in that view using values passed in from the tab view where the pickers are. So create a new SwiftUI view called Book List View. From the Books tab view, copy the entire contents of the navigation stack except for the title modifier. And then return to the Book List view and import SwiftData. And then replace the content of the body with that clipboard. You can then return to the Books tab view and cut out the state and query properties and paste those into the Book List view because that's where they needed. And then you can add the mockData preview trait modifier to this preview as well. Back in the Books tab view, in the body, we can remove that list and the sheet because that's now in our Books List view, and we can provide an instance of that Book List view here. You should be back in business here, so we can start to implement the dynamic sorting and filtering. To create a picker, I want to create an enum that is a string type, and it conforms to the identifiable protocol and the case iterable protocols so that I can loop through all cases and use the raw value to display the text. So for convenience sake, I'm going to create an enum at the top of the Books tab view. I can then call the enum sort order, and as I mentioned, make it string, identifiable, and case iterable. And there are 2 cases, just book and genre. I'm not going to include author here because of the multiple authors, so it doesn't really make sense to try and sort on authors. And for the ID, because of the identifiable protocol, I'll just return self. So let's embed the book list view in a VStack. Now our choice will be stored in a state variable that I will call sort order, and it'll be one of the types of sort orders, and I'm going to provide a default value of book. Now within my VStack, I can create a picker as the first item by looping through each case of the sort order enum and then binding the selection to that state property. Then within the picker, I can use a for each loop on the sort order's all cases to get an iterator instance that I can call sort order. And then I can present a text view with the string sort by, followed by the sort order raw value using string interpolation. So we'll need to pass this then onto the book list view when it's selected. So before we do that, then let's prepare for that in the view. In book list view now, we currently have initialized the query with the sort of books. Well, the only way we can change this is if we remove it from here and then set it in the initializer using whatever sort order is passed in from our tab view. So let's remove the sort from the query and create an initializer for the view that has one parameter, and that is the sort order, which is of type sort order. In the body of the init, then, we'll create a sort descriptor for book based on the sort order case. So first, we'll let sort descriptors be a sort descriptor of type book, and it has to be within an array, and it's going to be equal to one of the two different types. So we'll use a switch statement on sort order to get both cases. In the case of book, the sort descriptor will be book.name. And in the case of genre, it'll be a book based on the books.genre.name. Remember, sort descriptors have to be part of an array of possibly more sort descriptors. We're only passing in one. Then we can update the query using an underscore books, and that's going to be equal to a query where the sort is sort descriptors. Now the preview is complaining because we need to provide a sort order. So we can create a let property here for sort order, which is of type sort order, and I'll provide the same book case. And then we can use this to initialize our book list view. And then the last thing that we need to do is to return to the book tab view. And where we present the book list view, we'll have to also pass in the selection as the sort order. And now you can see in the preview, we have dynamic sorting. For filtering, I'm going to do the same thing. I'm going to create an enum with 3 cases, book, genre, and author, and then add a search field to the list that allows me to enter criteria. And when the selection changes, the filter will depend on the search field and the selection. Well, this year we're able to specify key paths that SwiftData can use to create one or more binary indices for the associated model. And this is known as an index. Remember, in the book model, I created that index macro for the name and genre key paths. Like a table of contents in a book, an index represents an additional metadata which SwiftData generates and saves in the container. And this metadata makes queries for specific key paths much faster and more efficient. So let's take advantage of that. In the Books tab view, let's create another enum like we did for sort, and we'll call it filter type. And it too will be a string that conforms to the identifiable and the case iterable protocols. So my 3 cases are book, genre, and author. And the ID again will just be self. So let's enclose the sort filter right now in an H stack. And then add a spacer, and it's after the spacer where I want to create the picker for the filter type. So we're going to need a state property for our picker, and we'll have to provide a default value. So I'll create mine, and I'm going to call it filter type and the default value I will default to book. So by default, we'll be searching on the book title. Now I can create the picker for filter type with the selection bound to that. I will use a for each loop on the filter type, all cases, and that's going to get me an instance of the filter type that I can use to present another text view for choice using the string filter by, and then I'll use string interpolation to present the filter type's raw value. And then to improve the UI to the entire HStack, I'm going to apply a border button style and some horizontal padding. So now we've got our picker, we need the search field. So we'll need to have a state property that we'll call filter that will initialize as an empty string. And then to create the filter field itself to the entire VStack, I'm going to apply a searchable modifier where the search text is bound to that filter. And for the prompt, I'll just use the string enter search criteria. Now again, we want this to be dynamic on our book list view, so we'll need to pass in both of these new state properties to that view in the initializer and respond accordingly. So let's go over to book list view first then, and let's add those two parameters to the initializer. First one's for filter type, which is of type filter type, and the second one is filter, which is of type string. And now, like the sort order, we can modify our query based on that content. Filters require a predicate, and like sort order, we can modify that via a switch statement to go over all three cases. So first, though, I'm going to create a predicate variable as a book predicate. If the filter string is empty, then we'll just use the predicate macro for a book and return all books. So just returning true. Now, if the filter is not empty, we must switch on the filter type and create a filter or a predicate specific for that filter. So we let Xcode generate all three cases. Let's start with the two that we could always do before, and that is to filter on properties that don't require a complex search, such as authors will because of the array of authors, and we'll be searching basically in two different models. So in the case of a book, we'll create the predicate macro on book, and then we'll return all books where the name, the localized standard contains the filter. So this will take both an uppercase and a lowercase in any foreign language accents and do that comparison. And we can do a similar filter for genre because each book has only a single genre. The predicate will be a predicate on book that'll give us a book where we will compare the book's genre names, localized standard contains, to the filter. In the author case, however, it's more problematic in that it requires filtering values in an array where the array properties are in that related model. And until this year, this couldn't be done in a predicate. Well, new in iOS 18 is the ability to use Foundation's new expression macro to build complex predicates easily. And expressions allow for reference values that do not produce true or false, but instead allow for arbitrary types. And they can be used then to represent those complex evaluations using the model's properties and composed within predicates to tailor the results of the queries even further. So I want a query that fetches any author where the filter will be contained in the author's first or last names, and those authors' names are modeled by authors. Well, we can't use a computed property here. So what I can do is create an expression that will return the number of authors in total that match that criteria. And I'm going to call this expression found authors count. Now, it will be equal to a macro expression with a result where we're using an array of author type, and it's going to return an int. But we get the author's array as an iterator that we can now filter. And we can use the author's first name, localized standard contains, on that iterator, or the iterator's last name's localized standard contains on the filter. And then we can return the count that we get. So it's going to search both the first and last names to see if that filter is contained in either one of them. So if a book has no authors that match that criteria, the result will be 0. But otherwise, it's going to be 1 or more. Well, this expression then can be used to evaluate each of the arrays in our books. So we can do that now when we create a predicate. So we'll let the predicate be equal to the predicate macro for a book to get the book instance as the iterator. And then we can build this compound predicate where the book author's count must be greater than 0, and the expression on found others count evaluates the array of book authors, and that returns an int, so it too has to be greater than 0. Now before I go on, it looks like I misspelled author here in this. So let me make that fix now. Well, now that we have the predicate, we can add it to the query before the sort. So we add the filter, and the filter will be that predicate. And we can fix the preview from complaining by creating default properties for the filter type and the filter. So the filter type will just choose the default book. And for the filter, we'll have an empty string. So now our preview is working. And then finally, back in our Books tab view, we can add those two state properties as arguments of our Books list view. Well, we can test this out now. And in the preview, you can tap into the search field and type something. As you start typing, the filter is immediate. And this time I'm typing king. And you'll see that the list filters down to present To Kill a Mockingbird, because the default is on the book title and king is within the word mocking. So it's filtered down to that single title. If I switch the picker, though, to be based on author, we get a filter to display all the books written by Stephen King, the one where he was an author or a co-author. If we switch the filter to genre, though, the list is empty because there is no genre with the string king in it. Now, if we clear the search field, the list returns. Since we're looking for a genre, if I start entering the string for fantasy, it filters down to show those 3 books. Well, that's it for this video and the series. So I hope you've learned something here that you can apply in your projects either now or going forward. If you've enjoyed this video, please give it a thumbs up and leave me a comment below. And be sure you subscribe to my channel and enable notifications so that you're made aware of new videos that I release. You can also download my free channel listing app to be able to search for and find content from any one of my over 300 Swift and SwiftUI related videos. Thanks for watching.